Okay, so sorry my camera died on me there. So we are doing the section again, rotations 3.2. The video kind of cut out on when we were talking about rotations above 360 degrees. So I'm going to show you a rotation of 750 degrees here. Okay, so rotating 750 degrees, and we're going counterclockwise. So counterclockwise would be going in this direction around. Okay, and obviously 750 is bigger than 360, which is one full time around a circle. Okay, so we're actually going to have to do multiple times around the circle to get to a full degrees of 750. Okay, so say we're starting right here, and we're rotating around our center point of the circle. So if I rotate 360 degrees counterclockwise, oops, that's a horrible circle, be going around like that. So one full turn would be at 360 degrees, so I'm not quite 750. If I do another full turn of 360 degrees, so 360 plus 360 is going to get me to 720 degrees, which is still not quite there. So if I'm at two full rotations, would be 720. To get to 750, I need to go an additional 30 degrees, because if I did 720 plus 30, I get to my full 750 degrees. So I did two full rotations. Then if I'm here and I rotate, I'm just going to kind of guess here, 30 degrees. That would be the same as a turn of 750 degrees. So really, you would end up in the same exact spot if you turn around the circle two full times and then go 30 degrees, so 750 degrees a total turn. You would end up looking in the same spot as if you just turned 30 degrees counterclockwise. Okay, so you'd make two full turns and then just a little turn for the 30 degrees to get your full 750. Okay, another way to phrase this is talking about it as revolutions. So revolutions is just one full time around a circle. So this would be one revolution, two revolutions, and then just a little fraction of a revolution for a circle. So what they want to know here is taking our revolutions, so 1.5 revolutions, and turning that into degrees. Okay, so if I go one full time around a circle, 360, and then a halfway around the circle, well, we know what halfway around the circle is 180, right? Like a semicircle. If we take those two values and add them together, 360 plus 180, we get 540, which would be 1.5 rotations, or revolutions. Okay, there is a formula we can use on this for numbers that are a little trickier. So what we can do is we can take our value for our revolutions, so 1.5, and take that times 360, a full circle. And if you do that 1.5 times 360, you get to that same 540 value that I said before. Okay, this is especially helpful if you get like kind of a weird fraction here and it's kind of hard to do or kind of hard to visualize on just your circles. You can just use this formula and that'll give you a conversion to your degrees. Okay, next thing here, we're going to flip back to our example sheet. And we are going to do example 2. Okay, so we've got quadrilateral Q prime, U prime, A prime, D prime is the image of QUAD under a rotation about the center P, and we're supposed to figure out what is the magnitude of rotation. Okay, so we are taking this shape here, we are rotating it around center P and getting this shape here. Okay, so they actually did the rotation for us, took and turned this shape to this shape around that point P. We have to come up with how many degrees we actually went. Okay, and the hint they give us is very helpful, and it says draw the angle AP A prime. So if we do that, so draw from A to P, and I'm going to shoot my lines out a little bit further because we're going to end up measuring here. And it's easier to measure if I shoot my lines out far. And then I'm also going to make from P out through A prime. Just like that. Okay, so now what I want to do is I'm going to measure that angle. So if I put the center of my protractor on that center point P, and then line up my 0, 1, 80 line with, really you could line it up with either line here, doesn't matter, you should still get the same angle measure. So if I line that up there, then what I want to do is I want to look out and see about where that line's at, and maybe I should have drawn it a little bit further there. But if I follow that out, it looks to be maybe at 116, because it's not quite to 120, a little bit farther than 110, little bit farther than that halfway mark there. So I would say maybe 116 degrees. And then we have to look to see if that's in the positive direction or the negative direction. So if we were starting with the point Q and going to the Q prime, U prime, all that stuff, we would be going in that direction, which would be clockwise. So if we're going clockwise, that would be a negative 116. Okay? Usually I give you quite a bit of leeway with these, so I would go, the book answer says that it's supposed to be negative 120, so usually I accept anything that's 5 below or 5 above, so I'd accept anything between 100 and, or negative 115 and negative 125 is usually how I do it. Okay, next thing is example 3, also in this packet. So example 3 is going to be this one here. So again, we're going to be doing a rotation, and this time we're going to rotate this shape here around point O, and we're rotating 60 degrees. Okay, so let's do that. So first thing we have to do with these is we have to shoot a line from one of the points that we are rotating, so like K, to our center of rotation. So I'm going to shoot a line from O to K. Then I measure my 60 degrees. So 60, since that's positive, that would be counterclockwise. So I need to be pulling this shape in the counterclockwise direction. So I'm pulling it in this direction. So when I line up here, I've got two options for my protractor. I could angle it to the right or to the left. Okay, if I go to the left, I would be pulling the shape in the clockwise direction. If I angle it this way, I would be pulling it in the counterclockwise direction, which is where I want to go. So I'm going to angle it like this. I'm going to put the center of my rotation on center of my protractor, line up my 0, 180 line with the pink line I drew there, and I'm going to make a mark at 60 degrees. So I'm going to go to here, 60 degrees, stick a point, then I'm going to shoot my line out. So from O out to that little mark I made. And we always draw our lines from our center of rotation, and we always do our measurements from our center of rotation. Okay? So then now what I need to do is I need to measure my distance from O to K, which would be, oh gosh, I can't even see it. 6'2" maybe. And then I do my same measurement out here. So hard to see with that camera above my head. Just gonna kind of guess in there, 6'2". Okay. So at that point, again, we label the ones that we're drawing our images as the primes, so that'll be K prime. Then we do the same exact thing with the next point. Okay, so I'm going to grab another pen here. If I can find one. Okay, so we would go from O out to, say, maybe J. So we go O out to J. Then we measure again our 60 degrees. We need to move it, so we put center of rotation, in the center of our protractor, line up our 0, 180 line with that blue line we just drew, measure out to 60 degrees, and we're using the 60 that would be acute because 60 is less than 90. Then we shoot our line out there from O out to our little tick mark that we drew. and then we measure our distance. So we're going to measure from O to J, which is about 8 or 8.1, 8.1, somewhere in there. So then we go O out on the line we just drew, the same distance, stick a point, and that point there will be our J prime. Then we repeat that process with our M point. So we go O to M, shoot a line, and anytime we shoot our lines, we're always going from the center. So O to M. Then we measure our degrees, so we're going to go center of our protractor on our center of rotation. Line up with the 0, 180 line, best we can. Make a mark out at 60. Shoot a line from our center out to our tick point or our tick mark. Then measure our distance from O to M. Which is 7.3-ish, somewhere in there. Do the same exact measurement from O out to the line you just drew, 7.3-ish, I think I said. And that point will be our M prime. Then we have to do the same process with our last point there. So we are going to go O out to L. And this is why the different colors can kind of come in handy so you don't lose track of your lines. So O to L, and then we do our measurement with our protractor. So we go, we go 0, 180 line lined up there, center of the protractor lined up. Measure out to 60 degrees. Shoot a line from O to that little mark we made at 60. And then measure our distance from O to L, which is 4.1-ish, 4.1-ish. Do the same distance from O out on that line we just drew. And that will be our L prime. Okay, so now what we need to do is we need to make sure that we connect these in the same order that they originally were. So we need to make sure the L and the M are connected. So L prime and M prime connected. Then I'm going to work my way around the shape. So from the M to the J, so M prime to J prime. And then from my J to K, so J prime to K prime, and then K back to L. So K prime to L prime. And it should, if everything went okay, this original picture here should look exactly the same as our new picture, just turned a little bit up. Okay, turned 60 degrees counterclockwise. Okay, so it should be a really, really similar shape. If it's off by a lot, one of your lines is probably off, or it could be multiple lines are off. Okay, so you might want to just not erase the whole thing, but maybe check each individual line itself. Usually people get screwed up when they go to measure their angles. They either measure it the wrong way, so maybe they'd start with their protractor that way instead of this way, and we want it this way because we're pulling it counterclockwise. Sometimes people try to line the protractor up with the points on the shape. We never do that. We always line the protractor up with our center of rotation. Sometimes people screw up when they mark their angles. They'll use maybe the 60 over here when you were supposed to use the 60 over here. A lot of places you can kind of get confused on that, so just kind of try your best and hopefully get a shape that looks like that. Okay, so that's example 3, and then the next thing here is using circles to do some musical stuff. So it says here that circles can be used to find the notes of major chords. And then I don't really know anything about music, so I don't really know major chords or anything like that. So if I sound dumb, it's because I have no idea what music even is or anything related to it, so I'm just going to try my best here. But we can use a circle to figure out major chords by rotating clockwise, okay? And they actually have a picture of this on page 123, if you want to copy that circle if you can. If not, it is in the little packet thing as well, once I flip to it here. So it would look like this here, okay? So what it says is the example that's here and the same one that's in the book is the C major chord is represented by the vertices C, E, and G. So I don't know anything about the C major chord, but the notes that must go with that would be C, E, and G, okay? So what they want us to do is they want us to use this device here to figure out what the A sharp major chord is, okay? And this is example 4, which is our last thing we're doing here. Okay, so right now, the C is the one that names this, okay? So C is in control of all the other notes here. Okay, so if we want to figure out the A sharp, if we go from C to A sharp, looks like we're going to have to go 2 spaces, and we're going to have to go, that would be counterclockwise since we're going up and around that way, okay? So to get from the C to the A sharp, we had to go 2 spaces. So now we're going to, let me get my other highlighter here, now we're going to use the A sharp as one of our new points. So if we had to move 2 spaces there, we have to do the same exact thing with these triangle points. So we need to move 2 spaces from the E in the counterclockwise direction, which if we go E 2 spaces, we would be on D. And if we move the G 2 spaces counterclockwise, we would be on F. So if you actually did draw that triangle in there, so A sharp, F, and D, can't see that very well, I'm just going to wing it, something like that. That triangle would be exactly the same as our original triangle, okay, because we moved the same amount of spaces in the same direction. So that C point was the one that came up with the name. So to get to the A sharp, which is the name of that one there, we went 2 spaces counterclockwise, so we had to do the same exact thing with the rest of our triangle points, move 2 spaces counterclockwise. So our notes for our A sharp are going to be A sharp, and then what's the next one? D and F. Okay, and I assume if you know anything about music that that's correct. I truly have no idea if that's correct or not, but I assume it is based on this example. Okay, so that's the last example there. So you've got page 123, 1 to 13 all. There's going to be some ones where you have to do the rotations and dealing with the pictures, so just try your best. If you're having a hard time doing the rotations, there is an extra sheet that is in the on the Google site on the extra handouts. There's a sheet on that kind of gives the directions for rotations. So if you're having a hard time rotating the figures and you need some kind of step-by-step directions, there's a document on there with step-by-step directions. Otherwise, you could watch some of these examples again as kind of another way to kind of help you through this. Okay?